So please give a really warm welcome to Karen Gualme, Principal Developer Advocate, and Prakul Agarwal, our Senior Product Manager for Machine Learning. Thank you. Enjoy.
Hi, everyone. Welcome to the session on bringing AI to your applications with MongoDB. I am Prakul Agarwal, Senior Product Manager for Machine Learning. So we are right at the cusp of what is being heralded as the fourth industrial revolution. Artificial intelligence is right at the core of it. It's leading to a transformative change in the way we work, the way we live. Although AI and its application is not something that's new and the implications in business are understood, AI became the talk of the town with ChatGPT. It was discussed across the boardrooms and developer teams on what it means for them. ChatGPT was the first application to reach 100 million monthly active users in just 2 months. There are similar attempts being made in the enterprise space that will lead to transformation of how we build our businesses. Gartner predicts 90% of all new apps built by 2027 will incorporate AI. So I have built my career in AI space across the spectrum. 0 to 1 ideation phase when I was my own startup, to dealing with the challenges that the Fortune 500 face, to training models for the cutting-edge self-driving cars in companies like Amazon Zook, Salesforce, before I worked at MongoDB. While AI models, methodologies, and toolings are being democratized and becoming more accessible than ever, one thing has remained a constant, and that constant is data and the challenges of operationalizing that data. Data is the fuel that superpowers your AI, that makes it relevant for you. With managing data, there are all sorts of challenges in terms of how do you think of this cost, the scalability, performance, batch versus streaming, compliance, etc. I'm very excited to talk about how MongoDB's developer data platform enables you to accelerate your journey and build AI applications faster than ever. Right in the morning, our CEO talked about how just in the quarter alone, more than 200 businesses in AI space were built on MongoDB Atlas. So we have a power-packed agenda for you. I, along with Karen, who has a long history of building applications at MongoDB, are going to talk about starting from practical examples of how you can bring AI to your businesses, to some code walkthroughs on how simple is it to build ChatGPT-like applications on your private enterprise data powered by MongoDB. With that, let me bring on Karen.
Thank you very much, Prakul. Hi, everyone. So as a developer advocate at MongoDB, my job is to write applications to show developers just how easy it is to work with data. Now, unlike Prakul, who's quite seasoned with this is all quite new to me. I would probably say a few months ago, I barely knew how to spell AI, so I was really, really excited to work on it. It was a big learning opportunity. Great to learn from one of the best, of course, but honestly, I was quite surprised about how easy it was to build AI into my MongoDB Atlas application. So today I'm going to show you why. Now, we do have a full agenda today, and as he mentioned, he has this amazing demo that we're going to get to, and he's going to probably be doing a lot of the technical heavy lifting. But before that, we're just going to open up with discussing the demand for building intelligence into your application in order to make these modern, highly engaging applications to make differentiating use experiences for each of your users. You could use it for fraud detection, chatbots, of course, as you mentioned, personalized recommendations, and beyond. So now if you're new to the AI space, perhaps you don't know a lot of these terms and the technology names that we're going to be talking about in AI. So if you fear that you're missing out on what all the new kids are chat-GPTing about, then don't worry, because we're going to define and demystify a lot of these concepts before illustrating them in context through the lens of an e-commerce application. And then we're going to go deeper. We're going to discuss some of the considerations that you need to make while you're building AI into your applications. And that could be anywhere from the architecture to the rich ecosystem and to how using Atlas or a developer data platform as part of your AI integration strategy from the beginning can really set you on the way to success into building AI into your applications. So as Prakul mentioned, 97%, 96% of applications are going to be using AI. It's going to wait for no one. So you need to be competitive in this digital economy, you need to be building intelligence into your applications in order to gain rich insights out of your data. The AI is going to power the consumer-facing aspect, whereas the data that you get from this fresh data, the insights that you get, is going to power a more efficient business decision model. Now, MongoDB works with a wide variety of companies across all of these industries right now, building AI into their applications. And although these are lots of very different use cases right now, they're all unified by their critical need to work with the freshest data in order to achieve their objectives in real time. To understand the challenge of this, first we need to understand the history behind this. So once upon a time, applications would turn to analytics in order to make sense of their data. They would analyze large data sets in order to gain the business values and help them make business decisions. Over time, as computing power increased, they were able to analyze larger and larger data sets in less and less time, thus setting the stage for the onset of batch AI. Now, batch AI is really fascinating because it's how you can analyze the user's activity and history and their interaction with your application, and you take that data to create models. Now, these machine learning models will then make predictions or inferences about your user's next activity going on and the future events that will go on. The more data over time that you feed your model, the better it gets, the more you can tune it, and the more accurate the future predictions become. So as you can imagine, this is really powerful, because if Prakul and I, for instance, can predict what's going to happen tomorrow, we can make some really great business decisions today. So batch AI, as the name implies, it's usually run offline and on a schedule. So it's analyzing historical data to make predictions about future events. But the problem with that is it can't, because it's on historical data, it can't react to events that happen quickly in real time. So this has its limitations. Although it's really great for industries such as finance and healthcare, we need data on things that are operating now. So there was a need for real-time AI. Now, real-time AI, we're analyzing live data to make these decisions for things happening in real time. So what that means is, this is really great for e-commerce applications where decisions are being made on rapidly changing circumstances. Fraud detection, for instance. Fat lot of good it does you to detect fraud if the person who's defrauding you has already walked away from the counter. So this is a good case for real-time AI. And then finally, that brings us to generative AI. Now this is cutting edge of AI right now. The whole concept of generative AI is that it creates new data. It creates new images, new texts. And because it creates new data, it goes a step beyond simple automated text. As a matter of fun fact for you today, these badges that we show on screen, we did not interface with our design team with them. We didn't cut a ticket. We didn't sit down and have a meeting. We used the AI model DAL-E to create them, and that's what we're seeing here today. Now, generative AI is in its infancy. It has some limitations and maybe some ethical concerns, but for today's talk, we're just going to talk about how these different steps in the evolutionary cycle of generative AI will play together inside of an e-commerce application. Now this app, Mongo Store of course, everybody should be able to go into their store, do search, find what they're looking for, and buy their product. but we can take a simple app like this and inject analytics on it in order to elevate the experience and personalize it and do many different things. I'll walk you through a few things here. So in my Mongo store, one of the first things I'm going to show you is how Batch AI can create a different use case, different recommendations for the different users. If I log into the store from my account, then this is going to take data that the store has about me, and it's going to run these maybe on a trigger, on a certain schedule, offline, to come up with recommendations for me. So you can see clearly what I'm in the market for, because it's captured my analytics. So it's capturing my analytics and my activity with the application. Now, I have a friend, Scott, and Scott has a bunch of buddies. They're going camping this weekend. He's very excited about his camping trip, but he doesn't know anything about camping. But you can see here that he has recommended items based on his recent searches. And if we look at his cart, he sees all the items a new camper needs, but this headlamp just goes out of stock this minute. And this is a really good use case for real-time AI, because we've captured that data and we can stream it along with product information of other customers and how they're using it to make suggestions to him. Now, I also use generative AI here because Scott is very excited about his trip. Now he has all the things he needs, but it looks like it's going to be really hot, and rather than sending him back to the search bar or back to the internet to look for needs or back to the Talking to His Buddies, he's going to ask, while we're here in the store, what he should wear when he's hiking. And you can see ChatGPT has returned to us data, information about what he'll need. He can keep the conversation going. So he started the conversation, we're still in context now, and he says, oh, you know what, it's raining as well. And then it's going to process what it needs to say, and it says, you know, if it's raining, then you need maybe these materials, maybe these equipment, maybe made out of these materials. And so the nice thing as well is that I can take this prompt that I've asked ChatGPT, but I can also prompt my model with my own private Mongo Store enterprise data. It can look for things from my product. It might look through things like questions and answers from other customers. And so I can give him these product recommendations. He can open it. And what I found really interesting is that these items that 30 seconds ago he didn't even know he needed, we can get it into his cart and at his doorstep in just a few clicks while he's ready to buy. So to sum up what you saw here, you can interact with the store, look for what you want, and capture those analytics. You could take those analytics a step further by, on a scheduled trigger, maybe run some batch AI models to send back personalized recommendations for your customer. We saw that Scott, when he with the data that's streaming, we saw that we can listen for when an item goes out of product. It'll execute some functionality in real-time AI so that he can get his headlamp replaced without sending him back to the search bar while he's at the purchasing stage. And then finally, we see that he can have this really natural interaction with our store. He can chat back and forth with our store, get the advice he needs, get the products he needs, and send him away this weekend, and Scott is a happy camper. So, these are some of the things that we were discussing building, some of the things kind of inspired us. I'm sure it's not even a fraction of what you guys can do. So if you guys want to tell us, we're super interested in hearing like some of the things that you want to build, and hopefully we can build it together. Thank you. Here you go.
Thank you, Karen, for that amazing evolution of an e-commerce store. With that, let's move on, like how this can be achieved. How can we help you with that? So, accelerating your AI journey. With that, let's do some level setting so we are talking about the same things. At a very high level, an AI workflow consists of 3 steps. The first step is what's called as the data preparation. This is where you take your data from different sources, make it into features that can be used for model training. Model training is a process where you use algorithms and feed your data so that it can learn. And the artifact that's generated out of this is what we are calling the ML model. So ML model is something that takes input. In the case of Karen's e-commerce store, it took in an input of users' browsing history of all the items that checked out and provides an output. Output in this case was a prediction of what products they would like to buy. With that, we move on to the stage of what's called as model inferencing. This is where you take these trained models and use it as part of your applications. So just to go over the workflow, we start with the application. Application is something that's powered by a database. So you bring in your other sources. So in this case of an e-commerce recommendation, maybe like information about customer demographics, etc. Combine that, prepare it in the right format, put that into a data lake, and that's something that's your model training will be operating on. With operated model, like you have a model registry which will store these trained artifacts, different versions. And then with these trained models, you use the model inference, where you would retrieve your features in batch from your data lake and load the predictions into your application database. So when the next time you log in, they have access to that. So how does the data platform for AI work, and how does it enable your journey? So MongoDB Atlas, right? We begin with, on the left, on all the things that you would expect any data platform to have. A great general purpose database, asset transactions for the critical loads to full text search. Things become interesting as this platform evolves, like things that you don't even, but as you're ready, that's there. So Atlas Vector Search, which we released and previewed today, is one such example. We'll talk about Atlas Triggers, which helps you generate embeddings on your data, helps you generate some of the model inferencing, to data lake, which can help you optimize the cost of your model training, to things like that you're ready for production, scaling multiple clusters worldwide, to things like security and compliance, right? You start from a prototype on your laptop, and when you're ready to sell to enterprise with the strictest of compliance, you are ready. That's what MongoDB Atlas lets you do. All this works with best state-of-the-art product around like the AI platforms, and all of this works out of a single unified query. So I'm going to talk about some of the enablers in the AI system that are there in this process of using this data platform. So there are a lot of them. I'm going to talk about them. So in the data preparation space, one of my favorites is this thing called Spark Connector. It lets you extend the power of MongoDB query language with Apache Spark right out of the box, where you can do feature engineering, use some of the ML libraries right inside your MongoDB with an adjacent Spark cluster. We have something called PyMongo Arrow that lets you use most famous data science frameworks like PySkit-learn, Pandas, with MongoDB's data based on easily converted into columnar store backed by Apache Arrow. All of this works out of the box. We move on to model training, and there are a bunch of things that help you move quicker. So offline feature store. Atlas Data Lake is great for building these offline feature stores, which are these data layer for your AI models. Feature stores let you centralize the processing of these features or data points using ML models. And with offline training, you want it to be easily accessible via batch and lower the cost of training, because that's how the algorithms work. You want fast access, you want cheap. And with that, there is the model inferencing. So just like we had an offline feature store, which was used for model training, we have an online feature store. Online feature store is also something that's called as inference store. And during the inference, you want to be able, your data platform, to provide really fast inference or data retrieval capability. Atlas Triggers helps you connect your changing data connect with your models of choice. So in this example, one of our customers described this whole experience of building as Apple of data platforms. Things just work seamlessly. You have your offline feature stores where you are dealing all your features. When you're ready to do inferencing, data integration, do a dollar out, things materialize in your online feature store. Everything is in sync. You don't have to worry about ETL, moving data around, managing multiple pieces of infrastructure. It all works out of the box. And this combined with the best industry partnerships. So among some of you are like, those leaders that I'm talking about. We have MindsDB, we have AWS, Google, all sorts, best of the best, right? So there's native integration to the most commonly used data science and machine learning toolkits, as well as established partnerships with leading providers. So let's talk about batch to real time. Like when we are talking about batch, we are really talking about that personalized recommendation that Karan talked about. So that batch is something that you would want to load those predictions maybe like once a day. So whenever user logs in, those are available. So at a high level, this is what the batch AI workflow looks like. And with the Atlas enablers and the industry partnership that I talked about, this really becomes into this piece. Like this is the Atlas ecosystem. While this may look like a complex diagram, what this really represents is the simplicity. Atlas allows you to use the tools, the frameworks, the toolkits that you're already used to, that your teams are used to, rather than forcing you to adopt something completely new, while providing you these features, enablers that just accelerate things for you. So with that, how will your status change like once you decide to incorporate real-time AI? With this, the real-time AI would be that lost cart item, like something goes out of stock, you are able to quickly replace it with something that customer will just love, right? They will not have to go back and search for it. So when we're talking about the real-time AI, you start with your application, you stream your data into a message queue. This gets persisted into your application database, and this gets directly streamed into your model inference. This model inference leads to the real-time prediction, which is served right inside the application. And this data is something that you would be using for model training, either online or offline. The beauty of this is across the streaming data, like we previewed Atlas stream processing that helps you do this. We talked about Kafka connector that lets you really work interchangeably with MongoDB as a sink or a source. So with minimal changes, you would be able to operationalize these real-time AI algorithms, models on your data. So with that, let us take a step back. Let me give you a thought exercise. So what if you had a mandate to build this vehicle maintenance application, which would have a consumer-facing app, as well as a web app for the workshop, and data flowing in all different directions and shapes so that you can predict when the vehicle requires maintenance, help optimize the supply chain, help optimize workflow for the workshop. So building an application like that is right with like pains and failures, because data and managing it can be such a terrible thing. You would have to bring up 10 different pieces, point solutions. You will have to put it all together, and you will have to bring in like large team for machine learning, right? That's what it would come to mind for a lot of you. So with MongoDB Atlas, I wanted to leave you with this reference diagram. On the left, for your mobile application and your web application, we have these SDKs and toolings. Makes it really simple. All your data sits in one data store. And on the right, this reference architecture is with like AWS, where you can use their AWS Sagemaker for being able to do your model training, do your auto ML, and we provide you the integrations to very effortlessly connect your data to Sagemaker, as well as serve the inference back when you're ready. We have code for this. We will be sharing all of those resources if of interest. So moving on to the chat of the town, generative AI, ChatGPT, all these models. So with that, let me talk about two fundamental concepts that have enabled this massive revolution that we are seeing right now. Just for context, the generative AI was that chat that we demoed where user can do natural language chat. It works beautifully, provide the recommendations from our private data. So the first concept is this thing called large language models, or LLMs. So the big change that's causing a lot of the excitement and the advancement is because these models are trained on vast amounts of information. So for instance, everything that's available on internet. So what that enables you to do is use these pre-trained models and use it for your application. These serve for broad purposes, very general purpose models. Earlier, with traditional AI, the batch in the real time, you had to train everything from scratch. So that time to value was higher. With this, you can get quickly started. So giving you two examples here of OpenAI's ChatGPT, asking it to write about an AI event in New York City, beautiful poem, and the prompts that we use for that image right there. The second concept I want to introduce that we talked about with the vector search is this of something called vector embeddings. So at a very simple level, vector embeddings are just these numeric representation of data and related context. This is transformative because it allows you to convert your unstructured data into the structured data. And structured data of fixed length is something databases are very good with managing and processing. In this case, you can take your text, your code, your images, your sound, your videos, apply a model, get this vector embedding. So vectors are not new, but the use of these large language models come out of the box and let you do amazing things with it is something that's great and exciting. So just for an example, take your text, use a text model, get your vector embedding. Voila, you can do semantic search, you can do recommendation systems on your text data now. Use your audio data, use a video model out of the box, or fine tune one of your own, get your embeddings. Same thing on your all kinds of application. Similar stuff for audio, right? Like all these different models are available, rapidly advancing. So with that, there is some limitations on this new world of LLMs. So one thing is, since it's really trained on same corpus, right? So if you give it the same question, you will get similar answer. So as a business, how do you differentiate it for your customers? How does it matter to you? It does not have knowledge of your data. It is not up to date on what's been happening. So if you guys remember the UK elections and all the prime ministers changing, good luck asking ChatGPT who the prime minister of UK is and getting the right answer. And finally, it can hallucinate. So hallucination is a term that's used frequently, and what that means is these models can give you an answer very confidently, which would sound like the right answer, but it's not. So let's take an example with that. So with this, I want to ask a question to ChatGPT, and the question is, how much better is GPT-4 in reducing hallucination over GPT 3.5? So GPT-4, GPT 3.5 are these two versions of models which powered ChatGPT. Let's see what happens. So with that question, it goes on to say a lot of words, and a lot of words to just say, I don't know the answer to that. So how do you solve for this problem? How do you make it relevant for you? Reiterating the point, your private data creates a differentiation with AI models, especially with these large language models. So we will talk about how do you use these foundational large language models to build applications with MongoDB. So there are two main concepts to get this up and running. So one is this concept called model fine-tuning, where you would essentially take your private data and do some model training, or what is called as fine-tuning on these foundational models, so you can extend the knowledge, get a new model, a fine-tuned model, and then proceed to use with your user query, get your user output. The second method is called as in-context learning. So this novel approach is what lets you not require you to like train a new model, but really use a few examples from your private store to be able to teach these models new information. This is something that's really transformative. It can allow your developer team to get started quickly on this, be very effective without requiring great amount of expertise, as well as has a lot of benefits with how you want to think about your data lifecycle, like challenges across that are there with model fine-tuning. So what approach you want to use depends on your use case. So, but in this case, we just talk about in-context learning, how MongoDB Atlas vector search will use that to actually answer the question we asked ChatGPT that it was unable to give. And in less than 20 lines of code, we'll show you that it's possible with like MongoDB and possible to do it in a scalable, effective manner. So let's go through that. So for this purpose, like writing this kind of a program, you can really write your own, or you can use one of the many partnerships we have. So in this case, I'm talking about this developer framework called Llama Index. In this case, we proceed with really initializing our model. In this case, we'll be using OpenAI. You can use Azure's endpoints to make it more secure or change the model. The first step really is loading your data, which we did. The second step is preparing data for these large language models. Just in these 2 lines of code, we converted that PDF into like these 107 chunks. With that, like it's really like a part of that PDF that we originally talked about, which had that answer. With that, we moved to persisting these prepared data into MongoDB. 2 lines of code, and you have your MongoDB database populated with some of the metadata. You can see the progress happening. We want to get like 107 chunks, which is what that has been parsed into. So that's complete. With that, the UI, it's super simple to get started, super simple to operationalize this. Now that we have the data, we want to connect that data to these large language models, create some of the embeddings. So to do that, we create something called a vector index. Vector index is something that we are using in this case, Llama Index framework, but this is backed by Atlas vector search as well as MongoDB Atlas. So vector search again, like would be converting those 107 chunks of text into a format that's easy to search around the semantic search use case. While that's happening, I just want to talk about the benefit of this flexible data model. When we are preparing data for different large language models, all of them require different preparation. They have different context length. So flexible schema really helps. As well as you can see that vector index that we were preparing, that's been created. So with that, now we are ready to query. So we go ahead and query this newly created index, this vector index. And in this, we'll show you that how easy is it to query. You do all of this preparation once, and then in your downstream application, you would just be triggering this query. How much better is GPT-4 in reducing hallucinations over GPT 3.5? And in this case, voila, here is our answer, that it's better by 19 percentage points. All of this happens in natural language. User will ask, as well as you can get some of the information. So in this case, we had these 2 nodes from those 107 chunks that had the relevant information. So we were able to do those right information and use all of that as part of these large language models, less than 20 lines of code, super scalable. So just to talk a little bit about the high-level overview, right? Like you begin with your private knowledge sources, MongoDB vector search, MongoDB index store, MongoDB document store is natively integrated to the leading developer frameworks, or you can build your own. Connect them. You provide a system of record for these embeddings. You can connect to different kinds of these large language models. There is OpenAI. There is Databricks Dolly, which is a partner of ours. Open source, closed source. There are all these different trade-offs. And then the user is able to interact in natural language, really. So MongoDB at the center, with its partnerships, makes it super simple for you. Like this is something that's available today. You can go ahead, try it out. The notebook that we talked about is something we'll be making available as well. So moving on, I just want to leave you with this reference architecture of building this chatbot securely over your private data. And this is something that we did with that example we just demoed to you. So knowledge sources, where Atlas fits in, and how your query processing will really work. Again, there is accompanying code and notebooks that we are happy to make available. So with that, I just want to talk about one last piece, which is one of my favorite ways of chunking data using various LLMs. And so I want to talk about you have your database set up, you have your collection. Let's say it's a customer support ticket collection that you have. So I'm going to show you one thing where you can do things like sentiment analysis, language translation, summarization of those data, where it would create like a new field in your existing collection very simply, so with using triggers. So triggers, just like you select your database and the collection you want on the kind of operation, update, delete, what kind of data change you want this to be triggered on. Super easy to configure in Atlas. This leads to triggering of a function. In this case, the function we are calling a model from HuggingFace, which is like a Distilbert, which is looking at the changed data and doing a sentiment analysis and persisting that back into the MongoDB collection. So your existing data with this manage offering just works. And you can integrate all kinds of different models, try out different prompts. Very well managed way of doing things. So with that, let me conclude. We are in amazing times. AI is transforming the world. And with MongoDB Atlas, you're just restricted by your imagination. And yeah, we are super excited about what we build and how we can help you out with that. So thank you so much. So if there are any questions, we'll be here.
Thank you so much, Karen and Prakul. Any questions from the audience? There are so many of you. Please raise your hand up high.
So we don't need to do that slide.
If you have a question, can you come towards me, please? Yeah. Sorry, thank you. Appreciate your patience on the acoustics. It's a bit tough in here, but we're making it through.
Hi.
Hi. I've seen this Longchain building a customized LLM with PDFs using some library from Longchain only, I guess. without even converting into the indexes, index data, I mean like vector embeddings, and storing into database or anything directly from reading the PDF and customizing the LLM. So what is the advantage of, like, say, taking this PDF, chunking into the thing and putting into vector database and then customizing the LLM?
Yeah.
Do you want to repeat the question?
Yeah, I can take that one. So with that, like...
repeat the question first.
So the question is, you were talking about like clarification around the workflow where we took that PDF or like a private data source and stored it into a vector database and then did this customization on different large language models. So like, so in general, the workflow thing is we do want to do the data preparation. So when we're pulling in the data with vector store, you will be calling your large language models to create the embedding. So that is the first entry point into how when you will be using your data. And then you will have to use the same embedding generation at the end to retrieve those. The second usage that we do is with the large language model where you get a query in natural language and return the response back. So those are the two places you're interacting with your different large language models. Cool. All right. So we'll be here. Thank you so much. Hopefully this was useful. Thank you.
Thank you, guys.